Hi. In this series, I will solve some all past exam questions by Nspire calculator. Read the question, please. We are given a displacement function of a particle for the first 5 seconds. We need to find the maximum distance from the starting point. Quick note, distance must be positive regardless of the direction of the particle. It's a paper 2 question, so let's start with the graph page. Pay attention to the unit at the top right corner of the screen. It must be a radian for a modeling question. If it is not, you can click on the unit and change it. For this, you need an updated operating system. Our independent variable is t, but on Nspire we need to change it to x. Let's change the view. We don't need negative values. 6 is reasonable. X maximum is 5. For y minimum, let's try negative 20. That's good enough. Okay, the particle goes approximately 3 cm right from the starting position, and it reaches the maximum position on the right and changes direction for the first time here. At x-intercept, it's at the starting position, then moves to the left. The minimum point on the graph is the farthest distance it can go, so we need to find the coordinates of the minimum point. Before we proceed, let's graph the velocity time graph. I press tab for the second, and from the symbol button, I recall the derivative function. We need the derivative of the first graph, which is the velocity time graph. As you see, when the particle reaches the maximum point, velocity is 0. Then it changes the direction. Then velocity is negative at this state. When it reaches the minimum point, velocity is 0 again. Then it becomes positive. Let's find the minimum point of the blue graph. Menu, Analyze, and Minimum will provide us. I want this graph. Define lower and upper bound. And here is the minimum value. At approximately 4 seconds, it will reach the farthest distance on the left side, and the distance must be 16.5, and you need to write your answer as positive. Second part of the question is asking acceleration when the direction changes for the first time. We already talked about it, so let's find the coordinates of the first stationary point. X coordinate will be time. We need to calculate the acceleration at this time. I click time once, then press variable and store it as t1. Second derivative of displacement function will provide us acceleration. So we need to calculate this function, which will be our acceleration. For this one, I will go to calculator screen. There are 2 options. One of them is using the symbol button. Here's the second derivative. It's a numerical derivative, so you need to define the x value. You can recall from here. And I want to calculate it at t1. Here's our answer. Second option, you can press menu, calculus, then numerical derivative at the point. Our value is t1, and we are looking for the second derivative, which is our acceleration. Define your function, then press enter. So negative 8.92 is our answer. Let's see another method to calculate it. On the graph page, press tab for another function. This time, we will sketch the second derivative of the displacement function. And the black one is the acceleration function. I press menu, then geometry, then point on. I will just click on somewhere on the black graph and locate my point. It is not the point that we are looking for. I press escape to quit. Then double click on time and press T1. And here we found the same result one more time. Thanks for watching. See you at another question.